The oldest comet ever seen. It's only the third time that we've actually detected an object that has come from beyond our solar system. With the report, here's our science correspondent, Georgina Ranard.
A wanderer from interstellar space named 3I/Atlas is hurtling straight toward the Sun. The greatest concern lies not in its speed or trajectory, but in its strange chemical signals. Initial analysis reveals the release of nickel gas with a complete absence of iron, something that should be impossible in nature. Familiar astronomical models are facing a shocking possibility. Could this be evidence of technology not of this Earth? The final answer will be revealed in October 2025, when 3I/Atlas makes a close approach to Mars and NASA spacecraft capture the first close-up images. What exactly are we observing? How can an object defy all known laws of astrophysics so profoundly? The story begins with a rock from beyond our solar system, moving faster than anything we normally see close to the Sun. Astronomers have named it 3I/Atlas, and from the moment it appeared on their screens, it has raised more questions than answers. It is racing at a speed of almost 130,000 miles per hour, which means it could cross the distance from New York to Los Angeles in less than a minute. At the time of discovery in July 2025, 3I/Atlas was more than 400 million kilometers away, but even at that distance, its unusual path made it stand out. Instead of following the neat oval orbits that bind planets and most comets to the Sun, it travels on a hyperbolic route. In simple terms, that means it is only passing through. The Sun cannot pull it into a permanent orbit. What makes 3I/Atlas so fascinating is not just its speed, but also its timing. It is moving inside the orbit of Jupiter now and heading toward its closest approach to the Sun in late October 2025. At that moment, it will still be far from Earth, about 270 million kilometers away, but it will slide near Mars on October 3rd, close enough that orbiters around the red planet might be able to capture its image. The direction it came from adds another layer to the mystery. Astronomers traced its origin back to the constellation Sagittarius, a region of the sky already famous for strange radio signals like the WOW signal of 1977. While this does not prove any direct connection, the coincidence is enough to stir curiosity. After all, Sagittarius is where the center of our galaxy lies, a place thick with stars and strange phenomena. Having an object fly out from that region and enter our solar system feels almost like receiving a messenger from the crowded heart of the Milky Way. Still, one thing has been made clear. 3I/Atlas is not a threat to our planet. Its path will never cross Earth. When it reaches its closest distance to the Sun, Earth will actually be on the opposite side, separated by hundreds of millions of kilometers. That should reassure anyone who fears a catastrophic impact. Yet the absence of danger does not mean the absence of importance. On the contrary, it gives astronomers the chance to study without panic, to observe calmly, and to focus on the deeper question: what is this object really? The size of its core remains uncertain, hidden inside a cloud of dust and gas, but estimates suggest it could be less than a kilometer across. That is small compared to mountains on Earth. Yet it is big enough to hold secrets about the earliest history of our galaxy. Think about it. This fragment may have been traveling for billions of years before crossing paths with us. It is not only older than human civilization, but it may even be older than the solar system itself. Every measurement, every spectrum of light it releases is like a piece of a puzzle that could tell us where it formed and what it has carried across the stars. The James Webb Space Telescope, the Hubble Space Telescope, and powerful observatories on Earth are all lined up to watch as 3I/Atlas approaches. The hope is that by catching it at multiple angles with different instruments, scientists can compare results and see if the object behaves like a normal comet or if it breaks the rules once again. The first part of this mystery is simple. A rock from another star system is flying through ours. But the more difficult part is still ahead. If it does not behave like other comets, if its gases, brightness, or movement show patterns that science cannot explain, then the story becomes much stranger. Could we be looking at nature's trick or something even more deliberate? That question leads us directly into the next piece of the puzzle, the chemical signs. 3I/Atlas has already begun to reveal, and those signs are unlike anything astronomers expected. The most unsettling part of 3I/Atlas is not its speed or its path, but what it leaves behind as it warms in sunlight. Every comet carries a kind of fingerprint in its gases, and scientists use these chemical traces to understand where it formed. With this object, the fingerprint looks distorted, as if someone had smudged the ink. Instead of following the familiar pattern seen in most comets, it releases chemicals in surprising amounts, and some are missing entirely. Normally, when comets heat up, iron and nickel are freed together because they are born side by side inside dying stars. They almost always appear in equal measure, but telescopes watching 3I/Atlas found something odd: the presence of nickel gas without any sign of iron. This imbalance has no easy explanation in natural chemistry. It is like seeing salt without sodium or smoke without fire. If nickel can be freed alone, then something unusual must be holding the iron back. Another strange detail comes from the detection of cyanide gas, a chemical known to exist in many comets, but the way it behaved here was extreme. As the object drew closer to the Sun, the amount of both nickel and cyanide rose far faster than expected. In a typical comet, these gases increase step by step as the ice warms and turns directly into vapor. The rise here was so sharp that it did not match any known model. That sudden spike left astronomers wondering if some hidden process was driving the release. The puzzle deepens when carbon dioxide is added to the story. Observations from the James Webb Space Telescope revealed that 3I/Atlas is unusually rich in CO2 compared to water, one of the highest ratios ever measured. For context, most comets follow a trend where water dominates and carbon dioxide remains in smaller amounts. Here the balance is reversed, suggesting a nucleus that either formed in a very cold region or has been altered by some unknown factor. This rare chemical makeup makes the comet stand out like a red flag among the thousands of icy bodies studied before. Water itself is present, but even that comes with surprises. Instead of large crystals or frozen blocks, the water in 3I/Atlas seems to exist as tiny grains less than a micrometer across. These grains were likely blown away from the nucleus by jets of gas rather than melting naturally. Their size and form suggest violent processes on the surface, processes not usually associated with a small body of ice and rock. Every measurement hints at an object that does not fit the usual categories. Some scientists propose natural explanations, such as an insulating crust that hides water ice or chemical reactions that release nickel selectively. Others suggest that high radiation exposure during billions of years in interstellar space may have altered the comet's surface, locking certain elements while freeing others. What excites researchers is the chance to test these ideas soon. As 3I/Atlas moves closer to the Sun, its activity will only increase. That means more gas, more dust, and more clues. If the strange imbalance of nickel, cyanide, and carbon dioxide continues, it will push the debate even further. The signs are already clear. 3I/Atlas is not behaving like an ordinary comet. By studying these gases, scientists can reconstruct the conditions where it was born, conditions that may have existed long before our Sun even lit up. But chemistry is only one side of the puzzle. Just as important is the way this object moves, because its path through our solar system is unlike anything seen before. So the next question is simple. Why does 3I/Atlas follow such a rare and precise route? If the chemistry of 3I/Atlas is confusing, then its path through our solar system is even harder to explain. Most comets enter at steep angles, cutting across the orbital planes of the planets like wild intruders. 3I/Atlas does not do this. Instead, its route lies almost perfectly in line with the flat disk where the planets move, a feature called the ecliptic. That coincidence alone would be rare, but the way it threads its way past several planets makes it even stranger. On October 3, 2025, the object will sweep past Mars at a distance of about 28 million kilometers, close enough for spacecraft orbiting the red planet to take direct pictures. Less than a month later, it will reach its closest approach to the Sun at 1.36 astronomical units between the orbits of Earth and Mars. After that, it will move on to pass near Venus in early November, Earth in mid-December, and Jupiter in March 2026. This series of encounters looks like a tour carefully arranged in advance. It is almost as if the object has been plotted to take maximum advantage of planetary flybys, the same trick human engineers use when sending probes across the solar system. Astronomers often design spacecraft paths with gravity assists, where a probe swings close to a planet and steals a bit of its motion to change direction or speed. The famous Voyager missions use this method to visit multiple giant planets. Seeing a natural object follow such a smooth sequence raises eyebrows. It does not prove intention, but it does make the coincidence feel heavy. The rarity of this geometry cannot be overstated. Interstellar comets usually come from high inclinations, cutting across the solar system quickly and leaving no chance to interact with several planets. The odds of one arriving almost flat in the ecliptic are very small. Some scientists have described it as winning the lottery twice, because not only does it have the right angle, it also happens to pass near multiple planets along the way. This combination pushes the object further into the category of the unusual. For observers on Earth, the path also creates problems. During the period of closest approach to the Sun, 3I/Atlas will be on the opposite side of the solar system. From our point of view, it will almost hide behind the Sun, making it impossible to watch with ground-based telescopes. That means our planet misses the best view, while spacecraft orbiting Mars or flying missions like Psyche and JUICE may have the advantage. It is a twist of cosmic timing that puts the most advanced telescopes far away from the closest stage. Even so, astronomers have worked out a schedule of observation windows before and after this solar conjunction. By September 2025, the comet should be visible in the constellation Libra, though too faint for the naked eye. After perihelion, it will reappear before sunrise in November, moving across Virgo and Leo as it fades again. These opportunities are narrow, but they matter because every brightness curve and every small shift in its trajectory can tell us if it is following the rules of gravity alone or if something else is nudging it. For that reason, many voices in the debate have moved beyond curiosity and into concern. If this path is natural, it adds a new chapter to what we know about interstellar travelers. If it is not, then we are facing a possibility far more dramatic. Could 3I/Atlas be older than the Sun itself? If the strange path of 3I/Atlas is enough to raise suspicion, then its possible origin and age turn the mystery into something much larger. Astronomers have traced its motion not just through our solar system, but across the Milky Way, and the results suggest it may have been traveling for billions of years. That means this comet could have been formed long before our own Sun came to life. Studies of its speed and trajectory show that it belongs to one of two great populations of stars in our galaxy, the thin disk or the thick disk. The thin disk is where most familiar stars, including the Sun, are found, filled with relatively young stars rich in heavy elements. The thick disk, on the other hand, is much older, home to stars with fewer metals and ages that stretch back close to the birth of the galaxy itself. If 3I/Atlas is truly a member of this ancient population, then it may be 7 to 14 billion years old, which would make it far older than the 4.6 billion year age of the solar system. This makes 3I/Atlas more than a simple comet. It becomes a kind of time capsule, carrying material from an era when galaxies were still young. The chemistry seen in its gases already points to unusual conditions, and linking that with an ancient birthplace adds weight to the idea that we are looking at one of the oldest visitors ever studied. To put that into perspective, if Earth's history were a single day, our planet formed around noon, life began in the afternoon, and human civilization appeared in the last few seconds before midnight. 3I/Atlas would be a traveler that set out before the clock even started ticking. How does an object like this begin its journey? Astronomers believe that long ago it orbited a star of its own, forming in the outer regions of a young system where ices could survive. Then something disturbed its orbit. A giant planet or even a passing star could have given it the push it needed to escape forever. Once free, it wandered between the stars, moving through the galaxy while entire civilizations rose and fell on Earth. Over time, its surface was altered by radiation, cosmic rays, and the endless cold of space, locking away secrets in its frozen layers. Tracing its exact parent star is impossible. The galaxy has rotated and shifted so much over billions of years that all memory of its birthplace is gone. Yet scientists can still narrow down the conditions based on what we see today. The high levels of carbon dioxide suggest it formed beyond the so-called CO2 frost line, in a region far colder than where water ice normally condenses. That detail alone tells us it came from a very different environment than comets we know from our own solar system. The possibility that 3I/Atlas is older than the Sun carries profound meaning. It means this is not just an icy rock from another neighborhood, but a survivor from the dawn of galactic history. Studying it may tell us how common such objects are, and whether our solar system is constantly visited by these ancient messengers. If they can cross interstellar space and survive for billions of years, then the building blocks of planets and life may be moving around the galaxy far more often than we ever imagined. So, while the path of 3I/Atlas feels like it was written into the sky, its age reminds us that it has been traveling longer than almost anything else we can measure. And that leaves us with another urgent question. How does this object compare to the interstellar visitors we have already seen, and what lessons can we learn from those encounters? 3I/Atlas is not the first stranger to pass through our solar system. The first was Oumuamua, spotted in 2017. At first, astronomers thought it was just an oddly shaped asteroid, but later observations revealed something that broke the rules. It showed no visible tail, yet seemed to accelerate slightly, as if pushed by some hidden force. By the time anyone suggested it might be more than a rock, it was already too far away to study closely. That moment is often described as a missed chance, because the data were too thin to answer the biggest questions. The second visitor was 2I/Borisov, discovered in 2019. This one looked much more like a typical comet. It had a clear tail, it shed dust and gas in familiar patterns, and it behaved in ways that astronomers understood. Even so, its chemical makeup showed small differences, enough to prove that it did not belong to our solar system. Borisov reminded scientists that interstellar comets are real and that they can carry with them materials formed around other stars. Placed beside these two, 3I/Atlas appears even stranger. Like oumuamua, it shows behaviors that do not match standard models, such as the unusual chemical signals and the precise path through the ecliptic. Unlike Borisov, it does not follow a simple comet script. At the same time, it is larger and brighter than oumuamua, which means astronomers have a real chance to collect detailed data this time. In many ways, it combines the mystery of the first discovery with the clear visibility of the second, giving science the best opportunity yet to solve the puzzle of interstellar visitors. The comparison also teaches us a clear lesson. Each time one of these travelers arrives, the window for study is short. Oumuamua showed us that hesitation can cost answers. Borisov reminded us that detailed monitoring is possible if we act quickly. Now, with 3I/Atlas, the stakes are even higher because its strange features demand constant observation. Astronomers across the world are coordinating telescopes from ground-based observatories to the James Webb and Hubble Space Telescopes in order not to waste this chance. This moment matters because it forces a bigger question. If 3 interstellar objects have crossed our paths in less than 10 years, how many more are passing unnoticed? And if we are missing most of them, what stories about the galaxy are slipping through our fingers? The answer may lie not only in comparisons with the past, but also in the bold theories that 3I/Atlas itself has inspired. Could it be more than a comet, perhaps even something made with intention? That is the question driving the most daring debate, and it brings us directly into the heart of speculation. Some scientists have suggested that 3I/Atlas could be more than a comet, and this idea has fueled one of the most daring debates in astronomy. The strange release of nickel without iron, the sudden spikes in cyanide, and the rare alignment of its path all look unusual enough to inspire bold theories. Harvard professor Avi Loeb has argued that such features might point to a technological origin, perhaps even a machine designed to travel quietly through the galaxy. He notes that if engineers were to build a craft with nickel-based coatings or adhesives, heat from the sun could cause those exact gases to leak into space. This line of thought connects to the dark forest hypothesis, which imagines advanced civilizations exploring without making their presence obvious. According to this view, blending in as a comet would be the perfect disguise. The almost perfect route through the ecliptic, passing near several planets, strengthens the impression of a plan rather than chance. To many listeners, it sounds like the storyline of science fiction suddenly colliding with reality. Yet not everyone agrees with this interpretation. Many astronomers stress that extraordinary claims demand extraordinary evidence. They argue that radiation damage, insulating crusts, or chemical reactions could explain the odd gases. Critics of the alien spacecraft idea warn that focusing too heavily on one exciting possibility can distract from careful science. In their view, 3I/Atlas may still turn out to be an extreme but natural comet, one that simply broadens our picture of what is possible in interstellar space. What makes this debate so powerful is that it can be tested. Spacecraft around Mars, along with Hubble and James Webb, may provide the sharpest view we have ever had of an interstellar visitor. If it glows with its own light, if its gases keep breaking the rules, or if its path changes in ways gravity cannot explain, the discussion will move from theory to evidence. So we are left with a simple but haunting question. Is 3I/Atlas a natural messenger from the galaxy's past, or is it something deliberately sent across the stars? The answer may redefine how we see our place in the universe, and it brings us directly to the conclusion of this story. The story of 3I/Atlas is not merely a routine astronomical discovery, but a powerful invitation for us to expand our understanding. This object challenges all familiar models with its astonishing speed, its rare and precise orbit, and especially its anomalous chemical signals, notably the release of nickel without any iron. Although hypotheses about a non-terrestrial technological origin remain controversial and require further substantiating evidence, its very appearance has compelled us to reevaluate the diversity of the universe. The most positive and profound message from 3I/Atlas's journey likely lies in the very curiosity it ignites. It reminds us that not fully understanding something is not a failure, but a gateway to great discoveries. Instead of fearing the unknown, humanity is collectively observing, analyzing, and eagerly awaiting the moment of closest approach in October 2025. This is a beautiful testament to the unending spirit of inquiry, the very thing that will carry us further on our journey to explore the vast cosmos.